In this lesson, we're going to factor to solve equations with squares. Example 1, how do I factor to solve equations with squares? So we're going to be solving these quadratics, and we know a quadratic equation, it includes an x squared. All right, so our first example in which we have done is we solve this like what we would call a fence problem by isolating the variable. I would simply come and I would subtract the 10. We have 2x squared is equal to 14. We would divide by the 2, and we have x squared is equal to 7. And then to undo that x squared, the opposite is just take the square root. And so I would be then having x then is equal to plus or minus the square root of 7. And you could go ahead and give the decimal form, or you can leave it right here like the square root. So that's the first example. The second example was when we solved this then by factoring out. And so we were looking for the greatest common factors. And so I was looking to see, well, what number can go into 6x squared that can also go into negative or minus or negative 27x. And so we know that a 3 and an x can go into both of those. And so 3x goes into 6x squared 2x times, and 3x goes into negative 27x minus 9 times. And then that's equal to 0. And so what we're left with then are two equations here. I've got the 3x is equal to 0, and then the 2x minus 9 is equal to 0. And then we would just simply solve, and x is going to be equal to 0. For our next one, we'd add the 9, so we'd have what? 2x is equal to 9, and then we would divide by 2, so we have x is equal to then 9 all over 2. So our two solutions here then are x is equal to 0 and x is equal to 9 all over 2. Well, our next example, notice here, if I were to come solve this one, it's a trinomial. Now, what I could do is I could subtract the 4, so I've got it equal to 0, but I'd have x squared plus 7x plus 10 is equal to 0. So notice that I can't solve this one by factoring out the greatest common monomial. And so I'm going to need another method in order to solve these. All right, example number 2, how do I factor to solve trinomials? All right, so we're going to do this part right here where we're just going to factor them, and then I'll show you then in the next example on how you'll use this then in order to solve the trinomials. So the first thing we're going to do is we're going to break this m squared plus 9m plus 14. We're going to break the trinomial into two binomials. All right. And just to show that there are going to be numbers and operations, I'm just going to put two place values there. And so what we're looking for then is we're going to look to see what is going to make up that m squared. Well, I know that an m times an m make an m squared. So that's for the first term. The next one that we're going to look at is we're going to look at this 14, and we're going to then list out all of the factors of 14. Because remember, to make that 14, it's going to be this number times this number. So let's go ahead and list out those factors of 14. So I have 1 times 14, and I have 2 times 7. All right, so now the part we need to look at is that we need to, out of those two, we need to make this middle number, which is the 9m. So we need to look at either adding or subtracting these two numbers that I've just come up with to make a 9. Well, obviously here, 2 times 7 is going to make a 9. And because everything's positive here, it makes it a little bit easier, because now I know that this is going to be a 2 and this is going to be a 7, and it doesn't matter, those could be switched around. And I've got the plus 9 and the plus 14. So everything's going to be positive here. And so to show you then, if I were to foil this again, I would have m times m is m squared. I would have m times 7, which is 7m. I could take my 2 times my m and get 2m, And then that 2 times the 7 is plus 14. And then when you add these two middle terms and simplify it, now we are back to the original equation, which is up top there, the m squared plus 9m plus 14. But the answer that we're looking for here is what is a factored form here. It's m plus 2 times m plus 7. All right, number 2, x squared plus 11x plus 18. All right, so we're going to factor this one as well into two binomials. And so the first thing we need to look at is that first term here, and we're going to determine then x times x is going to be equal to x squared. And then remember the second step here is we're going to look at the 18 and we're going to list out the factors. I have 1 times 18, I've got 2 times 9, and 3 times 6. Now what I'm looking for then is the factors then that are going to then make up an 11 in the middle by either adding them or subtracting them. And so I'm going to use this 2 and the 9. So again, I'll have 2, I'll have 9, and then notice then in the middle here, I'd have the 2x and the 9x. And because everything's positive here, we're just adding everything together, and I'd have a plus and I have a plus. And again, if you need to go back and you need to refoil it to just make sure that you've got the correct answer, you could do that as well. I like to just kind of check these in the middle and make sure that that is going to in fact add up to the 11x. All right, question number 3, we have x squared minus 6x plus 8. So again, we're going to factor this into two binomials. And we're looking at this x squared, and we know that an x times an x is going to be equal to that x squared. And then I'm going to list my factors. I've got 1 times 8 and 2 times 4. Now I want you to look at this minus 6x in the middle. We're needing a negative 6x, but then notice that that last term is going to be a positive 8. So we know that we're going to use the 2 and the 4. So we have the 2 and we have the 4. But in order to make that negative 6 in the middle, I would need to have a negative 2x and a negative 4x. So I'm multiplying that, and I'm multiplying those outside terms as well. That's how I'm getting those. So, well, two negatives make a positive. And so we have x minus 2 times x minus 4. And then that then is how we make these middle terms then to equal up to that negative 6x. All right, so I ended up having x minus 1 times x minus 3. And notice that we had the negative 1 times negative 3 equals a positive 3. And then the negative 1 times x is negative 1x, and negative 3 times x is negative 3x. And then that's how we made up that negative 4x in the middle. All right, so question number 5. Again, we're going to factor this into two binomials. All right, and so we have our m times our m, and now let's look at this negative 20, and we'll list the factors. So I would have 1 times 20, 2 times 10, 4 times 5. And now we want to make a 1m, a positive 1m. And notice how I have a negative 20. And so what that means is that one of these is going to have to be a positive, and one of them is going to have to be a negative. Well, let's just go ahead and we're going to put our 4 times our 5 right here. I'm also going to say, all right, 4m, and then 5 times m is 5m. And again, we want that positive 1m in the middle. And if one of these has to be negative and one has to be positive, well, then our bigger one has to be positive. So I would have a negative 4 plus 5. All right, and then when we would FOIL it and put it back together, we would have that original answer. So m minus 4 times m plus 5. All right, question number 6, y squared minus 5y minus 24. So I'm going to pause the video and so that you can then try this one on your own. Once you're done, resume the video and then let's check your answer. All right, so taking a look at this, we listed out all the factors and then we needed to make a negative 5y in the middle there. And so I took the 3 and the 8, but we had this negative right here. So we knew that one's going to be positive, one's going to be negative. And we know that it's going to be, we have to have the negative be on the larger number so that we get that negative 5y. So y plus 3 times y minus 8. All right, so now let's go ahead and let's apply what we just learned to now solving one like the problem we tried to solve in example number 1. All right, so how do I find the solutions or the zeros? So again, in order to then find the solutions here, we're going to make it equal to 0 here. And we have to start then by factoring. And we're going to factor that then into two binomials. So we know that x times x is equal to the x squared. And now I could come and I could list all of the factors of 48, except there's a lot of them. And we know that 1 times 48, we would be able to produce this plus 49 in the middle there. So I would have a 1 and a 48. And then because everything's positive, we're going to have the pluses, and now this is equal to 0. And so once you've got it factored, now we have these two equations. I have x plus 1 is equal to 0, and I have x plus 48 is equal to 0. And then I'm just going to subtract the 1. X is going to be equal to negative 1. And I'll subtract the 48, and x is equal to negative 48. And there are my two solutions. All right, so for our next one, we need to make sure then that we have it equal to 0. So in order to do that, we're just going to rearrange this equation by just subtracting 18 on both sides. So I'll have x squared plus 3x minus 18 is equal to 0. So I'm going to pause the video again. I'm going to have you then factor this, and then let's come back and you can even go ahead and solve, and then we'll check our answers. All right, so when I factor this, I had x plus 6 and x minus 3. And notice that I was trying to make this 3x in the middle. And because this 3x in the middle here is a positive, I needed to make sure that the 6 is a positive. Now, once we got to that part, we're just going to say x plus 6 is equal to 0 and x minus 3 is equal to 0. And we'll solve. I'm going to minus the x and get negative 6. I'm sorry, I'm minusing the 6, and I'm going to add the 3, and I'll get positive 3. So my two solutions here are x is equal to negative 6 and x is equal to 3. For question number 3 and number 4, I'm just going to talk about how to set them up versus completely solving them. The video is getting to be too long, and then it won't post. And so what we want to do is we want to bring them all of your terms to one side. However, you have to keep that lead coefficient has to be a positive. So I would not want to minus that x squared. Instead, I'm going to move by subtracting the 8x from both sides. I'm going to add the 12 on both sides. And then I would solve. So I would have x squared minus 8x plus 12 is equal to 0. And then I could solve. And our last one, number 4, we have g of x is equal to x squared minus 2x minus 24. And again, I just want to show you that let's just place a 0 there. And then we're going to solve it just the same way by factoring it into two binomials and then solving both of those. And if you want to move the 0 to the other side because it makes more sense, that is just fine. So in this lesson, we took a look at how to factor trinomials into binomials in order to solve these quadratics.